In today's lesson from Unit 1.1, we'll be discussing special pairs of angles. Our first pair of angles may be familiar to you from a previous math class, and those are complementary angles. Complementary angles are defined as two angles whose measures have the sum of 90 degrees. For example, in a diagram, we may see two adjacent acute angles that have measures that add up to 90 degrees. Or we may see them as non-adjacent, but still acute angles. For instance, angle R in this picture has a measure of 60 degrees, and angle T in this picture has a measure of 30 degrees. So just because they're complementary doesn't mean that they have to be adjacent to each other, but their measures do have to have a sum of 90 degrees exactly. Our next special angle pair are supplementary angles. And again, you may recall from another math class that supplementary angles are two angles whose measures have the sum of 180 degrees. And in this case, again, we may have two angles that are not adjacent, say 50 degrees for my angle A and 130 degrees for angle B. And even though they're not right next to each other, we can say that angle A and angle B are supplementary. We may also express complementary and supplementary angles algebraically. For example, in this picture, let's call this point G, this point E, and this point F, and name a point on that ray point D. We may say that angle DEF has a measure of x degrees, and the angle that is right next to it, adjacent to it, angle GED, would then have a measure of 180 minus x. So again, we can say that angle GED is a supplement of angle DEF. Our third special angle pair has kind of an awkward definition, and that is vertical angles. And so I'm going to describe how they're formed. Vertical angles are formed by two intersecting lines. You see we have four angles formed here. And we want to take a look at this angle. We're going to call it angle 1, and this angle, angle 2. So you can say that angle 1 and angle 2 are vertical angles. So again, they are formed by intersecting lines. And vertical angles are not adjacent to one another. We do have a theorem relating vertical angles, and that theorem states very simply, vertical angles are congruent. And again, this is a theorem. So in our diagram, angle 1 and angle 2 are vertical angles, so we can say angle 1 is congruent to angle 2, meaning they have the same measure. In our first example, it says to find the measure of a complement and a supplement of angle A if the angle has the following measure. To find the measure of the complement, we just simply take 90 degrees and subtract angle A from it. So 90 minus 35 gives us 55 degrees. And make sure you label it as the complement. To find the supplement, we just simply take 180 degrees, because if they're supplementary, they add to 180, and subtract 35 degrees from that. And so that's going to give us 145 degrees. And just make sure you take your time and check your math. In part B, the measure of angle A is just given to us as y degrees. So this time around, when we find the complement, we'll take our 90 minus y and just leave it as 90 minus y. For the supplement, take 180 and subtract y degrees from that, and leave it as 180 minus y. So in the case where you have a measure of an angle that's a variable, the way in which you would represent the complement and the supplement is an algebraic expression. In our next example, we just simply have to find the value of x, and what we notice in the picture is that we have two intersecting lines and they form a pair of vertical angles. This angle, marked with 3x minus 20, is a vertical angle with the angle marked with x plus 60. And we have our theorem from our previous page that says vertical angles are congruent. So that means that their measures have to be the same. So set 3x minus 20 equal to x plus 60, and then solve for x. So I'm going to take and subtract x from both sides. 3x minus that 1x leaves us with 2x minus 20 on the left-hand side of our equation, and that's equal to 60. Take and add 20 to both sides, so I'll have a total of 80 on this side. So we have 2x is equal to 80, divide by 2, and we end up with x is equal to 40. Now just watch out for follow-up questions in problems such as this. Although we don't have a follow-up question here, you might be asked to go back in and find the measure of the whole angle. So you would just take your value of x, which is 40, plug it back in, and do your math. And in this case, this works out to be 100, because 40 plus 60 is 100. And up here, 3 times 40 would be 120, minus 20 also gives us 100. So that's a great way to check your work. In our third example, it says if angle C and angle D are supplementary, find the value of x, the measure of angle C, and the measure of angle D. Be careful. We have to solve for x first, but then we have to plug it back in to find each of our two angles. But remember, doing that is going to help us to check our work. So the first thing we notice in this problem is that we're told that angle C and angle D are supplementary. So that means that the measure of angle C plus the measure of angle D is equal to 180 degrees. So next, use the substitution property and replace the measure of angle C with 3x. So take out the measure of angle C, put 3x in its place. Take out the measure of angle D and replace it with 2x plus 25. And we have our new equation. So that equation says 3x plus 2x plus 25 is equal to 180. And then solve for x. But don't forget, we have follow-up questions. Combine your like terms. We have a total of 5x plus this 25 is equal to 180. Subtract 25 to both sides. And we end up with 155. Be careful with that subtraction. Now we have 5x is equal to 155, and then take and divide by 5. When you take 155 and you divide it by 5, we end up with x is equal to 31. Remember, that's just part of our answer. We have to come back in and find the measure of angle C next. So the measure of angle C, remember, was equal to 3x. Now we know the value of x is 31, so use that substitution property to plug 31 in for x, and then do the math. And 3 times 31 is going to give us 93 degrees. Okay, so hang on to that. Go back in, find the measure of angle D by plugging x back into that expression. So we have the measure of angle D. Instead of it being 2x plus 25, we want to say that the measure of angle D is equal to 2 times 31 plus 25. So go ahead and multiply 2 times 31. You get 62. Add 25 to that. We get the measure of angle D is equal to 87 degrees. Now, since we know that the measure of angle C and the measure of angle D are supplementary, check your work. Take 93 and add 87 to it, and make sure that they add up to 180 degrees. And they do, so we're right. Our last example is the trickiest of them all. It's a word problem. And let's read it through once, and then we'll talk strategy. The problem states, the measure of the supplement of an angle is 3 times as large as the complement of the angle. Find the measure of the angle, the supplement, and the complement. What I would encourage you to do is first figure out a way to represent the angle, the supplement, and the complement. So just make a list. Angle, supplement, and complement. Alright, so we don't know the measure of the angle, so we're going to let that be our x value. Remember earlier we talked about how to represent the measure of a supplement algebraically? Well, here's where you're going to use it. If our angle is x degrees, then its supplement has to be equal to 180 minus x degrees. And likewise, the complement of this angle would be 90 minus x. Okay, now we're going to go back into the word problem. We're going to take it piece by piece. I'm going to show you how the equation can kind of write itself. It starts off by saying the measure of the supplement of an angle is. Stop when you get to the word is. Circle the word is. Anytime we have the word is in a statement like this, that's where the equal sign is going to go, because that is really stands for is equal to. Alright, so that's where the equal sign goes in our equation. And look what I just underlined in red. The measure of the supplement of an angle. Well, here it is, 180 minus x. So we're going to take that phrase and replace it with 180 minus x. So far our equation looks like this. 180 minus x equals. Now go for the next part. 3 times as large. So that means we're going to take 3 and we're going to be multiplying it by something. It says 3 times as large as a complement of the angle. And remember, we represent the complement of our angle by 90 minus x. So come back up. 90 minus x goes in the parentheses. So here's the rest of our equation. We have 180 minus x, we have our equal sign, and on the right hand side of the equation you write 3 times 90 minus x. So this piece up here, really important to start off with that, and then the equation kind of writes itself. Okay, now for the solving part. Distribute that 3 times 90, we get 270, and 3 times negative 1x is negative 3x. Okay, you can solve this in a couple different ways. I'm going to work on it so that the x becomes positive, so take and add 3x to both sides. Remember, this is negative 1x, I'm adding 3x to it, so I'm going to have a positive 2x. I have this 180 still, plus 2x now equals 270. Take and subtract 180 from both sides. It's going to leave us with 90 on this side. So I kind of ran out of room. Come over here and we've got 2x on the left-hand side of our equation. That's equal to 90. Take and divide by 2. We're left with x is equal to 45. Now you probably know what I'm going to say next. Watch out for the follow-up questions. And go back to the original, and it said find the measure of the angle. We did. It's 45. Find the supplement. 180 minus 45 is equal to 135. Again, be careful with that subtraction. And finally, the complement. 90 minus 45 for x gives us 45. And we're done.